Hey everyone. Alright, today's video is going to be over finding the surface area of pyramids. Your objective: I will be able to solve problems involving the lateral and total surface area of pyramids. So a pyramid is just a 3D figure that has one base and triangular faces. So the difference between pyramids and prisms is that prisms have two bases and a pyramid only has one. So we are going to focus on rectangular pyramids and triangular pyramids this year. So a rectangular pyramid has a rectangular base, and since that has four sides, it's going to have four triangles that meet at a vertex. And a triangular pyramid is going to have a triangle as a base, and since that has three sides, there will be three triangles that meet at that vertex. So keep in mind the base and then the faces. All right. If you have the height of a triangular face, so like right here, we can see the height and it slants. So we call that the slant height. And we are going to use that to help us find the area of each face. And you'll see what I mean by that in just a moment. So if we take the pyramids and we fold them out so that we can see their nets, this right here is the slant height I was talking about. Because if we were to pick this up, it would be slanted toward that top vertex of the pyramid. Okay, so just like with prisms, we are finding the area of each shape and then we're adding it together. So for a rectangular pyramid, obviously we have a rectangle and triangles, so we're going to need the area formulas for rectangles and triangles. For a triangular pyramid, we only have triangles, so we're only going to need the area of a triangle formula. Okay, so let's review. Lateral surface area means we are only finding the area of the faces and we are excluding the base. So if we had a triangular pyramid, the base, and here's the cool thing about pyramids, the base is always right in the middle. So I would just mark that out. So we're not concerned about finding the area. It's a rectangular pyramid, mark out the rectangular base in the middle. We are not concerned about that area. So then we would just find the area of each face and add them all together. Total surface area means that we are now going to include the base as we are finding the areas. All right, so let's do some examples together. So we are going to find the lateral and total surface area for this figure. So let's start with lateral. All right. I don't want to find the area of the base, so I'm going to put an X there. We're not going to work with that. Now, this triangular pyramid actually has an equilateral base, so that means that if this measures 6 feet, so does this, and so does this. All right, now this has a height of 8 feet, which means so does this this triangle and this triangle. Okay, so to find the area of a triangle, remember that is base times height divided by 2. So let's start with this. We have a base of 6 and a height of 8. So that would be 6 times 8 divided by 2, which is 48 divided by 2, which is 24. So the area of this triangle would be 24 units squared. Now, this triangle has the exact same dimensions, a base of 6 and a height of 8, so I already know that's going to have an area of 24, and same goes for this one. Okay, so now I'm just going to add everything together. Okay, I've got 3 4s, that makes 12. I've got 3 2s, which is 6, plus 1 is 7. So the lateral surface area would be 72 feet squared. Okay, now total surface area, we're working with the exact same figure. So I'm going to go ahead and label. I already know the area of these triangles is 24. So the only thing we have to do here is just find the area of the base. So the base is a triangle. It means we're going to be doing base times height divided by 2. So if we look at this triangle, it's got a base of 6 and a height of 5.2. So that's 6 times 5.2 divided by 2. I'm going to come over here to work that out. Alright, 2 times 6 is 12. 5 times 6 is 30. Plus 1 is 31 with 1 decimal place. So that would be 31.2 divided by 2. I'm going to come back over here, work that out. Alright, 2 goes into 3 one time with 1 left over. 2 goes into 11 5 times with 1 left over. And 2 goes into 12 6 times. So the area of the base would be 15.6. So for the total surface area, I just want to add the area of all of those shapes together. Now we know from the previous example that the 3 faces add up to 72. So I already know what the sum of those are. I don't know if you guys can hear that, but I think they're doing construction or something. Alright, so there's the total area of the faces. So now we're just going to add in the area of the base. Remember 72 is like 72.0, so we've got to line up decimals. And then just add it together. So we get 87.6 feet squared. Alright, example 2. We are going to find the lateral and total surface area of this rectangular pyramid. Okay, so for lateral, I'm going to put an X on the base. Remember, the base is in the center. We don't want to find the area of that. We just want to find the area of the triangular faces. Alright, so if this side measures 8 centimeters, so does this side. So I'm going to label that. If this measures 6 centimeters, so does this. If the height of this triangle is 14, then the height of this must be 14. And if the height of this is 12, then the height of this triangle must also be 12. Alright, so we know that for the area of a triangle, it is base times height divided by 2. So I'm going to start out with this top triangle here. We've got a base of 8 and a height of 14. And we're going to divide that by 2. 8 times 14 is 112. And 112 divided by 2 equals 56. So the area of this triangle is 56 centimeters squared, which means the area of this triangle is also 56 centimeters squared. Now, this triangle has different dimensions, so I need to find the area of that one. So again, we've got base times height divided by 2. So it's got a base of 6 and a height of 12. So 6 times 12 divided by 2, and that would be 72 divided by 2, which equals 36. So the area of this would be 36, and this is the exact same triangle, so we know it's going to be 36 centimeters squared. Alright, so we found the area of each triangular face, and now we're just going to add them all together. So we've got 56 twice, and then 36 twice. I've got 4 6s, that's a 24, carry the 2. 5 and 5 make 10, 3 and 3 make 6, 10 plus 6 is 16, plus 2 is 18. And I'm going to write that over here. So 184 centimeters squared for the lateral surface area. All right, now for total surface area, we're including the base. And we already know the area of each triangular face, so I'm just going to write that on there. So we've got 56 here, 56 here, 36, and 36. All right, so we have a rectangular base. So the area of a rectangle is base times height. So we've got a base of 8 and a height of 6. So that would just be 6 times 8, which equals 48. All right, now we already know from the previous problem that the sum of all of the faces is 184. And now we're just adding in the area of the base, which is 48. 4 plus 8 is 12. 4 plus 8 again, we've got 12, plus 1 is 13. And 1 plus 1 is 2. So 232 centimeters squared. That would be the total surface area. So notice that with total surface area, you can just take the lateral surface area and then just add the base to it, and you end up getting the total thing. All right, now it is time for you to try find the lateral and total surface area of this actually square pyramid. So we've got a square pyramid here. Remember, lateral surface area, you don't want the area, sorry, I'm getting tongue-tied. You don't want the area of the base. So you're not going to need that square base whenever you find lateral. All right, make sure that you answer your questions in Educanon and you show all of your work in your notes, and I will see you next class day.